Mrs. Shermana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for Academic Proficiency.
Welcome to the UGC lecture series in Computer Science. We have been seeing in detail about the programming concepts in the C language. In today's session, we will be seeing in detail about the pointer concept used in C. So before we begin, we need to know what is a pointer. We have been studying about the use of common variables in C. A pointer is a specialized memory variable that stores a memory address. Normally when we have a variable name, it stores a value. A pointer is different from a common variable in the sense it stores or accesses a memory address. And pointer variables are always denoted by this star asterisk operator. Now this operator has a special name which we will be seeing later, and the rules that are to be used when we give a pointer variable a name is the same as that it is for general variables, which we have seen in the previous sessions. That is, they should start with a letter, they can be a combination of letters or digits, and they are case sensitive. So a pointer is nothing but a memory variable which stores a memory address, not a value. So what are the features of pointers? Because it directly stores the memory address or accesses the memory address, it saves a lot of memory space. We don't have to allocate space for storing the name plus the value, then the type of the value. All that doesn't make much of a difference with pointers. When you define or declare a pointer variable name, it accesses the memory address, so it saves the memory space required for any operation. So the execution time also will be faster, because accessing the memory is the actual operation which takes a lot of execution time. So because it saves the memory space that is allocated for a variable, when we perform operations using these pointers, execution time becomes faster. We save time as well. An efficient access of memory with pointers. We don't need to waste space by creating copies for the same operation, like we have already seen in the previous sessions about call by value and call by reference. When we access variables using their addresses, we don't make duplicate copies. Whatever change is made to the address of the variable holds good everywhere. The change that is made is permanent. So the memory space is also saved. And they are used with data structures. Normally when we use data structures in C, we generally go in for pointers, because data operations involving data structures are normally very lengthy in nature and they need a lot of memory space, lot of variables are used. So in such a situation, if we go in for using pointer variables, we will save a lot of time, plus the execution time of such operations also will become speedy. And a pointer of any data type occupies the same memory space. It is not like a variable name. Normally in variables, depending upon the data type, whether it's an integer, it will occupy 2 bytes. If it's a character, 1 byte. A pointer variable of any data type will occupy in general 4 bytes. So these are the important features of pointers which we have to keep in mind when we write programs and do programming using pointers. Because when we see certain applications, there will be certain parameters by which the application should be performed. So in case we have to perform some application faster, we have to save memory space and we should not waste it. In such cases, we should understand that using pointer variable names will make our applications more easier and handy. So how is a pointer variable declared? Here are certain examples for the syntax. Int mentions a variable is of type integer. We are using that star operator or asterisk operator, and we are giving the variable name as x. The next is a pointer variable of type float. Now this asterisk is also called the indirection or dereferencing operator. Now this is the technical term that is used to refer to this, otherwise called multiplication or star or asterisk operator in C. So when we are using pointers, we will refer to this operator as an indirection or dereferencing operator. So what does this operator indicate? Why is it called so? It indicates that the variable is a pointer. Now if you see the first line, integer pointer x and integer x, both of them are two different declarations. Integer star x indicates that x is a pointer variable. If you simply give int x, it indicates that it is a common variable. So this presence of this asterisk operator only indicates the type of variable, whether it is a general variable or it is a pointer variable. And the second use of this indirection operator is that it indicates that the value which is stored in this pointer variable refers to an address. The pointer variable itself does not indicate the value. The pointer variable indicates that an address is being held by that variable. To access the value which is present at that address, we have to use this indirection operator. The use of this you will understand when we are seeing the example programs. Generally, if we say int x and x is equal to 10, it means the variable x itself is holding that value 10. But when we say integer pointer x, that x holds the address, only the pointer x holds the value. So, the use of that multiplication or indirection or dereferencing operator is that it is used to hold the address of the variable and it is used to access the value using the indirection operator. Now, this is how a pointer variable is represented in memory. Say this num is a pointer variable of type integer. So, this num is the variable name. When you mention this star num or indirection num or pointer num, it refers to the value, and when you simply say the word num, it refers to the address. So, here this num is holding the address 4066 and the value that is stored at that memory location is 20. That is what is indicated by this variable name and by pointer variable name. So, simply a pointer variable name represents the address. Simply if you say num, it holds the address. If you say star num, it holds the value which is present at that address. This is the most important thing that is to be remembered when we are using pointers. If by mistake we do calculations using the word num, it will simply be manipulating the addresses. We will either get garbage value or the compiler does not support such arithmetic operations, it will simply cause the program to hang up. So, this is the concept that is mainly to be followed when we are using pointers. To access the address, we simply use the variable name. To access the value, we use star variable name. So, now we are going to see how to display the address of different variables with values. Now, here we are not using pointers, we are simply seeing how with common variables, how to access the address. Next, we will see with pointer variables how the address is accessed, to see the difference between the pointer variables and the normal variables. So, we usually start the program with the main function and we are having three variables here: general variables, character type, integer type and float type. So, now we want the user to enter one character, one number and one float number, and we are accepting it from the user using the scanf statement. So, C is holding the character, I the integer and F the float. Now, if you see in the first statement, here we are printing only the values. So, value of C is percentage C and I is D and F is F. They are all format specifiers and we are printing CIF. Next, we are printing the addresses. Now, if you see how are we getting the address? We are getting the address using the ampersand operator. We have already seen while studying operators, ampersand is called the address operator. So, when we are using normal variables also, it is possible to access the address using the ampersand operator. But when we use pointer variables, this ampersand operator is not used at all. So, this is a way of accessing the address of the place where a particular value is stored without the use of pointers. Now, this is how the output looks like. Whatever you entered appears on the screen, plus we are printing the values and then the address. If you see the address of C is 4061. The next integer is 4062. This is because a character variable holds only one byte. So, the integer is stored immediately following that byte. And if you see the float value, it is stored at 4064. This is because integer occupies 2 bytes. So, based on the allocation of addresses, memory space to a variable of type integer or type float, according to that the address is varied for each value. This is how generally we use variables and access their addresses. Now we are going to see how to add two numbers through their variables as well as their pointers. That is, when we use common variables, how we get the sum, and when we are using pointers, how we get the sum. So, again we are starting the program with 4 integer variables A, B, C, D, 2 pointer variables AP and BP. And we need 2 numbers. If you are going to find out the sum, we have to enter 2 numbers. They are entered in A and B. So, A and B is holding the value. Now, this is the most important statement when we are using pointers. Now, the address of A is given to AP and the address of B is given to BP. We are assigning the address values to AP and BP. This is possible only because AP and BP are pointer variables. So in this case, only using a pointer variable you can assign the address of a common variable. So here A and B are common variables, AP and BP are pointer variables. So the address of A is given to AP and address of B to BP. Now here if you see, we are finding out the sum using the common variables A plus B, that is given to a variable C, and we are adding the pointers using this indirection operator. So as I have already told before, AP and BP hold the address, whereas pointer AP and pointer BP, they hold the values. So because the values are being added, it is just assigned to a normal integer variable. You don't need a pointer variable here, it is not a must. You can just have a general variable and whatever value is being added over here, you assign it to that variable. So this operation also does the same work. This operation using pointers also does the same work. So that is how, it's only the syntax that varies. When we use a pointer variable, you are using the asterisk symbol, otherwise you are simply adding the variables. So finally I am displaying the sum that is obtained by both the operations. So if my program is right, I have to get the same answer for both the operations. So that is how I get here as the output. I am entering two numbers 5 and 7, and the sum obtained using adding the common variables A and B is also 12, and the sum that is obtained by adding their values using pointers is also 12. So this is how pointer variables are added in C. Next we move to the possible arithmetic operations that can be performed using pointers. So arithmetic operations, we all know addition, subtraction, multiplication and division. Now this is how their addresses are manipulated. Here if you see, when I give integer I, so we know integer occupies 2 bytes. So the operations that can be done when we have an increment and decrement is having this particular effect of incrementing the value by 2 bytes. So here if you see, 4046 is the initial address. When I perform an increment, it becomes 4048, and when I perform a decrement, it becomes 4044. This is because 2 bytes are manipulated over here. An integer occupies 2 bytes. So if I give increase, the address is increased by 2, and if I give decrease, it is decreased by 2. The same thing if you see for a character operator, their initial address is 4053. If I perform an addition, it becomes increased by 1, and if I perform a subtraction, it becomes decreased by 2. This is how the addresses are manipulated. Finally, you have the float value where the initial address is 58. On incrementing, it becomes 62 because the float occupies 4 bytes, and if I decrement, it becomes 54. It is decreased by 4 bytes. So this is how when we perform arithmetic operations using pointers, their addresses are changed. So this you have to keep in mind, so that when we perform programs, you will know whether your result obtained is right or wrong. So we will see example programs with these arithmetic operations after the break. Welcome after the break. So before the break, we had seen about an introduction to the pointer concept in C, the definitions of pointers, their features, and what are the arithmetic operations that are possible with pointers, how their addresses are increased or decreased. Now we will see how the addresses are manipulated by an example program with pointers. So here again I am starting the program with the main function. I am having two integer variables, one is a normal variable, the other is a pointer. So int I and int pointer I. So I have to enter the value. I need to store a value in the variable I am entering the value 8. Now we will be seeing how the addresses are changed by using the arithmetic operators. So now I holds the value 8 and the address of I is put into II. This is because II is a pointer variable. So now star II holds the value 8 and simply I holds the value 8. The address of I is held in II. So these are the three things you have to remember. So first line, I am here printing the address of I. The address of I is stored in II. So the initial address that is to be printed is 4060. So when the program starts, the variable 8, its value is held in the address 4060. Next I am manipulating the address by performing this increase operator plus plus II. So what happens? The address will be incremented by 2 as we saw on the last slide. So this 4060 is incremented by 2. Why? Because it is an integer variable. In the next statement, I am again incrementing the value of this address by another plus plus. But again here the output is only 4062. This is because this is a post increment operator. When we saw about operators, we saw that a post increment operator's effect will be seen only after the statement is printed. So here this II will be printed first and then the value of this address will be incremented. So the same 4062 that is printed in the previous line will also be printed over here. But after the number is displayed, after the address is displayed, its value will be incremented by 2. So after the execution of this statement, the value of this will be 4064 because of this post incrementing operator. So in the next step, when I give printf address of I am giving minus minus II. That means the value of this II will be decremented by 2. So when this 4064 is decremented by 2, it again becomes 4062. That is the reason in all these three statements, in spite of these operators being performed, their effect is seen only after the operation. So here because the value is 4064, it gets decremented to 4062. Now in the next step, again I am using a post decrement operator. So only after this value is printed, the value of the address will be decremented. So 4062 is printed as such, and when this decrement operator's effect is seen, the value of this 4062 will become 4060 because of this decrement operator. And the last step I am printing the value simply II. So now the value of II is 4060 that is printed over here. So this is how the increment and decrement unary operators can be performed with pointers, and this is how their addresses vary. Now a common confusion that can occur here is, here it is incremented by 2, so here it should be 4064. You have to remember that because it is a post increment operator, its effect will be seen only after the number is displayed. That is why the number displayed is 4062, but later the address is added to 4064, and when it is decremented over here, it becomes 4062 again. And here because it is a post decrement operator, the same value is printed. After printing the value, it is decremented by 2. So this is how unary operators have their effects on pointers. Next we see about the arithmetic operations using pointers. Like we have already seen a program for addition using pointers and common variables. Here we will see how we are doing other operations like division and modulo. So again here having two variables, here I have given the variable values in the program itself, and I am declaring two integer variables also, pointer p and j. And once I declare a variable, I have to give some address over there. So the address of a and b I am storing in p and j respectively. Now in just a single statement, in a printf statement itself, I am performing the addition. Now here if you see, addition of a and b %d I have given. This is a pointer variable and this is a common variable. Now this pointer variable's value is accessed using pointer p, which is nothing but 25. Because a's address is in p, so pointer p will hold a's value. So 25 plus b is the common variable that is holding 10. So here if you see, I am adding one pointer variable and one common variable. This operation is also possible using pointers. So the value of 25 plus 10 will be 35. The next step, I am subtracting the operators the same way. Pointer p is the value minus b. Again here a pointer variable and a common variable. Here instead of using pointer p minus b, I can use pointer p minus pointer j also, because j is holding the value of b. So these are the different ways in which operations can be performed using pointers. 25 minus 10 gives the value 15. Now here is where I have used that concept, multiplication of a and b. Here I am using both the pointer values, pointer p multiplied by pointer j, and next in division, pointer p divided by pointer j, and next in to calculate the modulo, pointer p modulo pointer j. So these are the ways in which arithmetic operations, unary as well as binary, can be performed using pointers. We can either manipulate the values by accessing them using their pointer variables, or we can have one pointer variable and one common variable, or you can have both pointer variables also. Only thing we have to remember is when we use a pointer variable to access the value, we have to use the indirection operator, and if we want to manipulate the address, we simply have to use the variable name. These are the concepts to be remembered while using pointers. So what are the operations that are not possible with pointers? First is addition of two addresses. We can only increment or decrement addresses with pointers, as we have seen. We have not performed binary operations like addition or subtraction with the addresses. That is not permitted in C. Multiplication of addresses is not permitted. Multiplication of addresses with any constant is not permitted. Division of address with a constant. So if you see, none of the binary operations are permitted with addresses, between addresses, or with address and a constant. Binary operations, arithmetic operations can be done only with their values. You cannot directly manipulate addresses with constant or with each other. Increase and decrement unary operators alone can be done with addresses. So this is another important point to be remembered while using pointers. Now next we move over to this concept of a pointer with a pointer. Now we have seen one pointer variable which holds the value and the pointer which accesses the address. So for the address we simply get the variable. To hold the value we get pointer variable. So what is this pointer to pointer? Every pointer variable has an address, and the pointer variable contains the address of another pointer variable. Now we will see this with a diagrammatic representation through this program. So here if you see, you have the main function, you are having a common variable a single pointer variable pointer p, and a pointer to pointer variable pointer q. So this is how we declare a pointer to a pointer. So here we have to assign the address of a to p. So this a's value, this 2 is held in pointer p, and here you see we are assigning the address of one pointer variable to another. Here p itself is a pointer variable, that address is being assigned to this q, and then now we are printing the value of a and its address, a and ampersand a. Here we are not using pointers, we are simply using a and we are using ampersand a. Now if we had wanted to display the address using pointers, we can simply give a and p over here, because p is nothing but the address of a. I have used address of a here only to show the use of the address of operator. Instead of using ampersand a, you can use p over here also, it will directly display the address. Now how is this ampersand p given to q? Now this is a diagrammatic representation. A is the variable which holds the value 2, p is a pointer variable that holds the value 2. So star p means it will give 2. Simply p means it will hold the address of a, which is given over here. So address of a is 4056, which is stored in p, and pointer p holds 2. This pointer q, star q holds the value of p. Star q will give you the address. So simply if you give q, it represents 4058. If you give star q, it represents 4056, the address of p. If you give star q, it holds the value of this p. So a pointer simply holds the address. So pointer p, if you give, it will give you the value. If you simply give p, it gives you the address. Similarly for q, if you simply give q, it gives the address of p. If you give star q, it holds the value which is holding the value of p. If you give star q, it holds the value of p. So here in this statement, if you see, through pointer p, I am getting the value of a and the address of a. So the value of a is given by pointer p and the address of a is given by simply p. This is a common pointer concept. Now this pointer to pointer, that is what is displayed over here. P is getting the value 2, star p is giving the value 2. Through this pointer to pointer variable, the value of a is obtained by star q and the address of a is obtained by star q. That is what is indicated over here. Star q holds the address of p. Star q holds the value of p. So this is the pointer variable. Normally this pointer to pointer concept confuses the programmer when he is evaluating the memory space. So generally these concepts are used only when it is highly essential to save the memory space using pointers. Normally a pointer variable itself saves a lot of space as well as execution time, but for you to know that this pointer to pointer concept can be used in C in case of situations where memory space is required, I have explained this pointer to pointer concept. It is only the use of an extra indirection operator. In a pointer variable you have a single indirection operator to access the value. In a pointer to pointer you have two indirection operators to access the value. And to access the address, in pointer to pointer you have single indirection operator. In simply pointer you do not need to use any indirection operator. Simply if you give the variable name, it will give you the address. Whereas in pointer to pointer you have to give one indirection operator and the variable name. If you remember it this way, it is easier to access the memory location and write your programs. So the questions that are possible in this session are: what are pointers? Pointer is a memory variable that holds the address of another variable. The features of pointers we have seen. They are used using the indirection operator to indicate the value of the variable and to show that it is a variable that holds the address. They save a lot of memory space and the execution time is faster with pointers. The use of this indirection operator is indicating that the variable is a pointer, and indicating that when we use pointers we can access the value of that variable. Simply if you use the variable, it will give you the address. And how does one pointer point to another? You have to declare it using of what type it is, give the indirection operator, give the pointer name, and after you declare it to be a pointer you have to assign the address of another variable to this pointer. Like we said, integer star pt, pt is equal to ampersand a or ampersand b or whatever it may be. And the possible arithmetic operations with pointers is, if we are going to use pointer addresses we can perform increase and decrease operations. But if you are going to use binary operations, we can perform it only with their values. We cannot manipulate arithmetic binary operations with their addresses. So in today's session we have seen about the definitions of pointers, the features of pointers, why they are mostly used in C, the arithmetic operations that are possible with pointers, the operations that are not possible with pointers, the concept of a pointer to a pointer, and the example programs indicating the syntax, and when you declare a pointer variable, how to assign the address of another variable to this pointer variable. So in this session the only thing that could confuse you is the concept of this pointer to pointer. To understand that concept better, just remember that a pointer to pointer you need to use two indirection operators. The first indirection operator represents the address of the previous variable, two indirection operators to get the value, whereas in a single pointer variable it is one indirection operator and no indirection operator for the address. So these are the main concepts involved in C programming using pointers. The way to use pointers with arrays and strings we will see in the next session. Thank you.